Welcome everybody to the July meeting of the Homebrew Robotics Club. We have a very exciting doubleheader. Stephen Williams is going to talk us through LLMs, and Survy is going to show us his 3D printed cell phone based RoboMagellan robot. So this will be awesome. All right. So how we normally start these things is with industry news. Somebody got some industry news out there they want to talk about?
Oh.
Industry news.
Well, that's strange. Oh, there he is. Can you hear us?
Okay? Yes, we can hear you.
Okay. Sound check. 5 by 5.
Industry news? Okay, I got something. The Unitree, I think I posted this to the mailing list. I may not have. Let me share my screen. I put a link. Unitree's got a new humanoid robot price from $5,900. I think that's going to be $12,000 once you include the tariffs. We'll have to see. But let me share my screen here. It's pretty cool. Now, and I've got another link to share regarding the. And somebody posted it some time ago about Optimus robot Tesla. And with the Tesla robot, it's all about the hands. And so, this guy's all athletic and everything and can run and jump and, leap tall buildings in a single bound. But, it's got no hands. And at the end of the day, it's about manipulating stuff. This guy comes from the guy that just wants to make a smart table. But anyways, this is the new Unitree R1 robot coming down the pike. They say priced at $5,900, so that's pretty cool. I'll put a link in the chat. Also, compare that to here's the new video. Musk had trouble apparently with the build that he was trying to do recently, but they've got a new Rev 3. And these guys, unlike Unitree, have spent quite a bit of time, energy, effort, and money on the, am I still sharing my screen? Yeah, hands. And so I think the hands in the Tesla, don't hold me to this, have 22 degree of freedom by itself. I mean, it's like a real human hand with the way they do the pinky and the thumb and all that kind of stuff. So, where a lot of these other guys, Boston Dynamics and so forth, seem to be more interested in the body movement and stuff like that. These guys have paid a lot of attention to the hands. You can see it there. You see in the video?
Oh.
Anyways, I put a link in the chat, so.
Oh.
Yeah, there it is. Any other industry news this evening? All right, let's move on into club news. I know we got Maker Faire coming up. Marco, you want to talk about Maker Faire?
Oh, there, right there.
Okay, yes, we were accepted again, and Maker Faire will be the last weekend of September, so 26th through 28th, something like that. And you are somewhat frozen. Now you're gone.
Sorry. I'll put the link in the chat for the Bay Area Maker Faire.
So let me know, whoever wants to come and show something. We probably have at least one table again. And the last 2 years, we took over a little bit more than that.
So that's Maker Faire Bay Area, September 26th through the 28th. And that'll be in Vallejo. Beautiful downtown Vallejo. So Marco put something in the mailing list on that, and participate. Don't be a spectator. Right, Dee Dee?
Yeah, yeah. I also have a Maker Faire booth as well, so I hope to bump into everybody there.
Excellent. That's the place to be. What is your you got the
Uh,
what do you have this time?
Well, headlining is still the humanoid comedy show, so we're
Okay, excellent.
updating it.
And move robots.
Yeah, so last year there was a whole humanoid block, and my next door neighbor made it into the front page of the Maker Faire magazine.
Very cool.
So that was cool.
This Unitree R1 looks pretty cool, huh? The Unitree robot that I showed a little earlier,
Uh-huh.
the humanoid.
Yeah, it looks
The
very
video looks like it's AI generated to me, though. I'm not sure
Uh,
what good a gymnastics robot is if it doesn't have any fingers that can actually do anything useful.
Yes, but if you want to play in this market, you need to get in where it's at and be experienced with it. And this is the starting place for it. So yeah, I agree. It's all about the fingers and the digits, but still getting from one place to another. And, if you're waiting till it's all developed and so on and so forth, you're not going to be part of developing it. Captain Obvious here. Any other club news? Maker Faire.
I'll be at the
September
Maker Faire.
26th to 28th. Say?
I'll be going. I have a booth at the Maker Faire for Team Kiss Robotics.
Okay. That'll be Beer 2, D2, and Chucky.
Yeah, 2 Chuckies this time.
Very good.
I'm working on one right now. It'll be on a motorcycle with his wife, Tiffany, and Ozzy Osbourne. They're all there.
Awesome. Steve Nelson, ladies and gentlemen. Okay. Let's move along. I need help with, is there anything, some specific thing somebody needs some help with? I want to talk about specifically? Maybe got some help from someplace somehow that got you moving ahead. I know we talk about in the Ross discussion group, seems like we're talking more and more with AIs. There was a point where Mr. Mike had to step away from the meeting and consult Claude. And Sergey's like, what? The group's not good enough for you? It was hilarious, but it's the truth. It's the truth, right?
And Claude lied to us.
Yeah, well, there's that. You got to keep them honest.
You were talking to us with Claude.
Yeah. So we've we'll just move on into show and tell here if that's okay. And I've gotten some good help in the Ross discussion group with Mr. Mike and Sergey. And here's the deal: is the ultrasonic. We now have a NAV2 plug-in for the homebrewed ultrasonic sensor. When we last left off, we took the Ross 2 Simple Publisher and displaced its hello world text message with a range message from a Python ultrasonic program. So here in RViz, you can see the ultrasonic cone. Actually, I don't want it protruding out. Let me try to get it away from this. I'm going to use the teleop and move it a bit. Move it this way. Okay, so here, clear the map. No, it's not going to cooperate, of course. So I've got this this fine homebrewed target here, mobile target, And what I'm going to do, typically I had been mapping and navigating with the LiDAR. You can see the LiDAR scans there. But what I'm going to do is I'm going to put this target in front of the ultrasonics, and you can see it. You can see the ultrasonic cone go out. You can see that, yes? And come in, right? Can you see that? Yes. Is this thing on?
Yes, I see it. Looks good.
Okay, and moreover, you see a cost map, that light blue inflation layer there. I'm taking it away there. Now I'm going to clear my local cost map manually. Never mind the man behind the curtain. And so that clears out the local cost map in front of it. But the thing about that local cost map, oh, sorry, that isn't what I wanted to do. Control C. The local cost map tells the local path planner to go around it. So when it sees that cost map, it'll go around it. The idea is a smart table is a tray table that can reliably get from one place to another. And it's done with a robot vacuum cleaner, but you need something to safeguard the upper structure. So without any further ado, I'll attempt a Floorbot challenge phase 1. So I'm going to say, actually, this works out pretty good because let me flip flop my phone around for a second. Her, sorry. Bear with me. Okay. Trying to flip the screen. I'm going to tell you what. Let's just do it this way. Okay. So you see that kitchen table, or you see that coffee table there is perfect because the robot vacuum cleaner will go right under it. With the ultrasonics, it should go around it. So let's do waypoint, and I'll go from one end of the room. Whoopsie. Hang on, let me cancel that. I want to do waypoint. I'm going to set a goal here, point, press, drag, mouse up, and set a goal here, point, press, drag, mouse up. So it should go back and forth past the coffee table. Start waypoint following. This is the nav planner here. And let's see. Okay, there's that. So it's actually navigating around the coffee table. I'm going to help it out. I'm going to clear its local cost map. I'm going to cheat more. I'm going to chili off it.
I know.
Am I still sharing my screen?
Yep.
Yes, you
Okay.
are.
Thank you. Okay, it's trying to, okay, there it goes. It's gotten, okay. And let's see if it gets that goal. Okay, so it's got the first goal, now it's going to the second goal. Help it out with a clear the local cost map. Again, the vacuum cleaner would go under that coffee table. What we're doing is we've successfully navigated around it with the homebrewed ultrasonic sensor. Clearing my local cost map again. I've got artifacts in there that don't clear. We're still working. But the point is that we solved and figured out a lot of this through the Ross discussion group. Again, thanks to Sergey and Mr. Mike. Let's see if we can make it to the goal. This is nav 2 here. We'll clear that local cough out. Hey, goal succeeded. You see that? Thank you very much. Any other show and tell this evening? Dee Dee, is that you?
No, I was just applauding.
Oh, hard to impress, but easily amused. That's the Ross discussion group on Tuesdays. So everybody's on the mailing list. That's where you find out about this stuff. Oh, come on. We got another show and tell out there somewhere, don't we?
Yeah, I got a show and tell. Yeah,
Who's that?
Nathan.
Nathan, go for it, Nathan.
All right. It doesn't do anything yet, but I did finish printing it yesterday. So, let's see. It's got the
Partial credit. Good for partial credit.
All right, yeah. So I know a couple people have been posting about them in the mailing list, but there's been, as of late, there's the whole Hugging Face SO Arm 101 project, and there's also the Lake Kiwi or Lay Robot Lake Kiwi base, and so they kind of, the idea, I believe, is to have basically this like common reference robot base for them to deploy all of their to target with like their AI tooling. And so they distribute the thing as it's been essentially just a GitHub repo full of 3D printable parts that they say to put together, and it's based on those wave shared serial bus, like basically they're Dynamixel clones. It took a couple of days to print everything out correctly, and there's like a pound of plastic in it or something, or there's a kilogram of plastic in it. But yeah, I mean I printed pretty simply.
So this is an arm. This is an arm, right? Okay.
So yeah, so it's an arm on a holonomic base.
Oh, okay, that's awesome.
Yeah. So the base is from some group out of UIUC, and then Hugging Face designed the arm, but they're kind of doing this thing where they have just this whole thing's like their reference platform. And so it's meant to use it like a Raspberry Pi. And so what I did is I printed the whole thing out of carbon fiber PETG, and then the little rollers on the wheels are TPU. So actually I did print everything. I didn't buy these wheels. So basically the wheels are just 3D printed frame, and then there's just basically 1.6 millimeter aluminum rods that you cut to length, and then you stick little TPU rollers in it to make the Omni wheels. And then they're the same one that can't remember who linked them into the mailing list, but the wheel model off of Thingiverse wasn't designed to work with these servos, so I modified the model and basically put the servo mounting hub just into the wheel model, and then printed it so it's just a single piece that bolts onto the motors, rather than needing like little printing out from adapters. But
What's that project? What's that project called?
It's called I'll post in the list, but it's called Lake Kiwi, LE Kiwi, KIWI. And the arm is called SO Arm 101. But I'll link it in the list, or in the chat.
Gripper opening big enough for a beer can?
It is not, and I'm working on designing a new gripper for it. Because
I think
it's only like
I
this,
put it in the
this
chat.
claw, like a crab claw or lobster claw kind of gripper. So I want to like make one that's like 2 fingers that are like moving perpendicular, actual like grippers that move like parallel rather than this rotating finger.
Or those soft compliant ones.
That's so what I'm thinking of doing is basically printing since I already have these servos, and so they work as servos or continuous rotation servos. What I'm thinking of doing is essentially printing my own linear actuator, basically printing the screw, and then basically doing one finger has forward threading and the other one would have reverse threading. So you just turn the rod one way and they'd close, turn it the other way and they'd open. Print like a little housing, and maybe I can still mount it on here. But
yeah, I put a link for that in the chat there.
Okay, awesome. And eventually, they don't. I think they didn't provide any they provided a URDF, but they didn't provide any of the ROS information for it. So one project will be trying to pull the arm into ROS, because they give you the URDF, but they don't give you any of the things for ROS. So if you want to switch the two together and make it work, you can. But that's not their.
What about navigation on it?
I would
Might
have
that-
put like a LiDAR or something, like one of those.
Okay, but might that be applicable to Lino Robot? They have a
Probably, well, I think,
holonomic. They have a
yeah, Lino
holonomic
Robot has
model.
Mechanism like chassis like support,
Mhm.
so
Yeah,
that'll probably be my first Lino robot. So
there you go. Lino Robot. It's a good model. What else? What else do we have for show and tell this evening?
I have something here, Cap, George.
Go ahead, George. And I see Mr. Mike. You're next.
Okay, I've got a PhD friend that I met about a year ago, and he's gotten me into a whole different aspect of things, but I think this applies to robotics. But right now, we're using these little sensors that are gas sensors. Okay, now what I see in the way of a robotics application of this is, let's envision one of these gas sensors that would be on a robot, and you could drive it into an area and check for something like excessive carbon dioxide or whatever other sensor you happen to have on the robot. So this would be extremely easy to interface with most any microprocessor. And I've got it right now. I've already done this with an Arduino, but I've got it set up. Here's one of them that I have set up now with a little display. It's hard to read that, but this is running off of a Raspberry Pi Pico in a breadboard configuration, and that's the number which is hard to read there, is being displayed on that little display. But it's extremely compact.
This is sensing gas.
Yeah, it senses gas, and I got 9 different gas sensors for $14 off of Amazon, and like I said, they're real easy to set up. You can pick up the voltage off of the either Arduino or whatever microprocessor you're using, and then you just connect the SS. What is it? Well, let's see. It has AO and D2.
So this would be for sensing gas around the house or something. I mean, you're talking about being on a mobile robot now?
In whatever, yeah, what I envision is in whatever, for instance, under the house, or
Yeah. I can see it for an industrial application or a construction application. Yeah.
Yeah. Anyway, it's a kind of a variation on what I've been doing with robotics. Anyway, it's a fun project.
Didn't you use a gas sensor for a distance sensor one time?
No, not me.
No, you were using your gas sensor, but it was for some other function than that, and I thought it was for like optical detection or something like that.
I don't recall it. Anyway, this has been a fun project, and these little display units are so inexpensive. I can't believe it.
Oh yeah, I've seen those. Yeah,
they're SSD 1306s, and use I2C, and they're just a lot of fun.
Seems like they're putting them on everything now.
Yeah, they're just a whole bunch of fun to play with. Anyway, that's been what I've been occupied with lately.
When you sense the gas, how do you calibrate it to give you back a reading? Are you getting it back in parts per million or something like that?
Very good question. Very good question. And that's the reason I yield to my PhD friend. But right now we're just in the stage of seeing what we can find. Now, it turns out you'd be amazed if you look up MQ dash, and then there's a whole series of just single digit numbers, or some of them are more than that. But you can look up and get data sheets off of the web, and you can see what the characteristics of these things are. So yeah, the next stage would be trying to figure it out. You know, what you can measure in parts per million for something like CO2, et cetera.
Okay, thank you very much. Thank you very much. Okay, let's move on. We've got a lot of things to do. Mr. Mike, I think you have something for show and tell.
Yeah, I'll just do a quick showing here.
No, yeah, there he is. Okay.
So my robot Sigan has a bunch of embedded boards on it. And I think I'm up to the 7th iteration of these boards that I make. So here we go here. So there's this smaller board here, which has on it a bunch of multiplexed I2C connectors, some non-multiplexed I2C. It's got 4 paired level translators I use for sonar, 2 SPI connectors, a CAN bus connector, 3 UARTs, 8 analog inputs, 4 PWMs, and 4 level translated relay drivers on this thing. I have this bigger board that has 3 custom power supply inputs. You can select the power supplies for these 16 PWM, multiplex PWM connectors. Again, another 8 I2C multiplex sensors or connectors, 3 UARTs, 2 non-multiplexed I2C. What else we got over here? CAN bus, 8 multiplexed analog sensors, 4 SPI 2 or 4 SPI channels over here. The sonar things, it's got the Ethernet connector, USB host, battery backup for the real-time clock, digital I/O pin expander, which also expands out there. So I do have a couple extra of these things if people want them. I did these things in JLC PCB. The actual cost to make the board with getting the parts stuff is on order to like $3-4 a board. And once you add in the tariffs and you add in the shipping, it cost me $300 to make 5 of these, I think, something like that. So if anybody is interested, let me know. I'll sell you one for $50. And I've been working on documentation, which includes
That's the rare part.
yeah, a big schematic, and there's a big thing here which has, how to drive each of the little sections of the board with some little code snippets and so forth. I've done it for the little board. I still need to do it for the big board. So, but I use 3 of these in my SIGIN, and I do hard real-time scheduling on all of this stuff so I can get high frame rates at a known rate to support the reliable navigation and things like that.
And what microcontrollers can you use with them?
Oh, this works just with the TC 4.1.
Okay.
So the TC 4.1 is like an Arduino on steroids on crack. So yeah, it runs 600 megahertz clock, a megabyte of RAM, about 40 I/O pins, including the Ethernet and all these things. And it's got a whole lot of built-in stuff for digital signal processing, and it's got a bunch of DMAs. It's got more functionality than you know what to do with. So this
you
stuff
probably-
is,
You use that as a subsystem.
yes.
And so how would you communicate back to a bigger microcontroller?
So I used to do it with Ethernet.
Okay.
But it turns out that, if you do Ethernet, you have to put a switch on there.
Yeah.
I used to have 6 computers on my thing. And the switch and the power and all that just took up too much room. So now, then I went to micro ROS. But micro ROS is brittle. And when you accept updates and you do customization so that you can get bigger messages and more publishers and things like that, it's just too freaking brittle. So now I wrote custom code that just uses USB serial. And since it's USB 3, it's hundreds of megabits a second. Works really slick.
And so the Teensy has the USB 3.
Yeah, and every Teensy has a unique serial number. So writing a UDEV rule to give these symbolic names works really easy.
Nice.
Thank you. Thank you very much. It'd be a shorter list to ask what it doesn't have. It's a kitchen sink board. Very good. Excellent work, Mike. Thank you very much. Mr. Crawley, Dr. Crawley, how you doing? I see you out there. All right, what's going on?
So I brought the Magni Mini, what we're calling the Magni 6 Mini, this is going to go on our website next month. You'll see it like August 20th, I think is when we're going to do that. One thing that I would like to, so what you've got in here is you've got motor controller plus our Raspberry Pi. This is going to be the same motor controller, same Raspberry Pi that we use on our Magni MIDI, which is going to be the same size as our Magni 5. And it will be roughly the same as the one that we're going to use on our Magni Maxi, which will be 1,000 kilogram size of a small, walk behind tractor. On this, there is what we're calling Pico ROS, which is ROS that operates right down on a microcontroller. So there's no need for drivers for the motor controller. You just simply plug the motor controller in, connect it to the Raspberry Pi, and everything operates over serial. So no need for drivers, no need for a separate ROS node. All that you need to have is a Zeno router on board, and then away you go. You can run your whole ROS 2-based system on Zeno, as many of you already know. The code for Pico ROS is open source. So if you go to GitHub/Pico-ROS, you'll see it there, and we have a full stack that's ready for microcontrollers right now. Other than that, Magni Mini, everyone. Soft launch next month.
What can you do with it?
What can you do with it? Well, we have, like any robot, it can drive around, has a differential drive, and so on, so on, so on, and so forth.
Yeah.
On top of that, we have our Easy Map stack, which is a web-based interface. So you can then set up routing. You can set up routing on that with a graphical, something that operates on something that operates on a web browser, so anybody can use it. That you don't need to use command line. You don't need to have Linux. You can just have anything that has a web browser can connect to the robot. You can set up SLAM maps. You can set up fiducial maps as well. You can set up a combination of SLAM and fiducial maps. You can set up routes. You can and so forth. Okay. These are
Expansion ports, or
they're ports for sonars, actually. So we've got a design for board with automotive sonars. This one is not fitted with them, so you just need something to make it look pretty.
So David, I'm going to a website that's Micro ROS, Raspberry Pi, Pico, SDK. Is that it?
No, GitHub/Pico, capital P, Pico-ROS. So capital P, small I-C-O dash ROS. Pico ROS, not Micro ROS. Micro ROS is something else.
Got it. Pico ROS.
And you can see the code there.
Cool. I'll put it in the chat.
And then that loads onto any. We set it up. We developed on STM32, but it is theoretically able to operate another microcontrollers as well. Okay, we've tried to keep it relatively microcontroller agnostic. But yeah, go out, take a look, and then we'll go from there. We are also going to be releasing. So we have Easy Map, which is for local control, but we're also going to release, just like I've always done with ROS, we're going to be releasing a distribution of OpenRMF, so you can then do fleet control as well. Okay.
Hey, David?
Yeah.
Can I get you to hold the mini Magni in front of the camera? Let me get a beauty shot of you there. Yeah,
Okay.
move back a little bit. No. I want you in the picture holding the robot.
You want me in the picture?
Yes,
sure?
be in the center of the picture. There we go. Hold the robot. Yeah, there we go. Hold the robot out. Okay. Work it.
That better?
Hang on. Let me get one more shot here.
Beauty shot with me in the picture. I don't know what you're talking
There
about.
we go. You gotta work with what you got.
Oh, there
Okay,
you go.
that's it. Thank you. That's it.
That's right.
You have a projected price yet?
We're still working on the price. We're trying to get it below 500 for everything, including Raspberry Pi, motor controllers.
Yeah, that's awesome. You guys should do real well with that.
But it might initially, it might wind up being a little bit more than that initially, okay?
Can you
So,
include the tariffs?
yeah, there's
Did
nothing
I say that?
there's nothing that I can do about, tariffs.
Come on, David.
I
You
thought they
got
came out
power.
for-
Go in there and tell them who you are.
How much things are.
Tell them you wrote the book on supply chain management. You know who you are.
Well, as you know.
All right. What else for show and
Oh,
tell this
watch it,
evening?
watch
What
it for it,
what
and
is
I know that I'm a Chinese boy, right?
what a spectacular show and tell.
As you know, right? So you all know that I'm a Chinese boy, but a lot of this actually is being made out in Slovenia right now, so I suppose we don't have to contend with lunacy tariffs. We just have to contend with slight.
All right.
tariffs, okay?
Hey, guys, we're running a little late on show and tell, so let's go ahead and move into the presentation. This evening, proud to present, let's see what we're presenting. Stephen Williams with LLM. Stephen, go ahead, take it away.
You want to do yours first?
Sure.
Why don't you do yours first?
Okay.
And then I'll fill in whatever time we have left.
Okay, I do have to prep the demo, so yeah.
Well, I can start then.
But I don't want to cut your presentation.
Yeah.
Yeah, it's okay. Okay, we can just do the demo in the Q&A section. So
Okay.
yeah, happy to go
Stephen
first.
Williams, take it away.
All righty.
Oh, so you are going. Okay.
I guess I will.
I don't think you.
All right.
Mine is also just 30 minutes, so you don't need to.
Let me make sure I am sharing.
Oh, yeah, go ahead.
Where is it? There it is. Okay. So this just came out of discussion. Well, I noticed these court cases and I posted something to list and we discussed it a little bit. We talked about doing this as a discussion. So if anybody has comments on the slides, go ahead and blurt them out and we can talk about it. So this really covers two things. One is for the AI machine learning training versus copyright issues and the recent court cases, court decisions about that, and just, what are the implications there? But then really that was a detour from the general idea of how can we use machine learning training to control robots, to, maybe take care of things like controlling multiple, complex joints in complex robots, et cetera, without sort of doing it in a more mathematical way. So I kind of cover some things related to that also. So, and this is just the general scope about that. And so the case that got me talking about this, I guess, was this one from ALSUP. And I don't know if you guys have noticed, but I've noticed over many decades that ALSUP has made key copyright decisions that set precedent that for major things. Like I think
Where's he located?
in the Bay Area. So I think he's in San Francisco. So like things that come to mind are like the look and feel back in the Apple versus Microsoft and a number of other cases that I feel like he's been the guy that usually ends up making those kinds of decisions. So this is potentially they're going to continue fighting about this. So who knows what happens on appeal? But often when they give him the big decisions to make, he makes the big decisions and they usually stick. So what he basically found was that training machine learning models on copyright material is fair use generally, because, as he says, it's exceedingly transformative. And one of the exceptions in copyright law is that if you are transforming something enough, that it becomes a new work and is not necessarily considered a derivative work. And there are a whole bunch of different shades of fair use, and so this can fall into that. Interestingly, the news articles didn't make it completely clear, but I think one of the big implications is that while you can create a model that was trained on copyrighted material and then use it generally, if you manage to use it in a way that just spits out the copyright material, then that of course would be infringing, right? And so then there's probably like a spectrum where things become gradually more infringing, and there's some kind of threshold, and that's kind of what fair use is.
Where would that get settled, in a court of law?
Well, eventually in a court of law, but there's kind of practicalities, and I've actually been kind of thinking about what how this should work, and so I don't think anybody's really worked it out. There are some existing precedents for things like ASCAP for music, and there's a few other cases. Music has become kind of weird because people started sampling, and then at first it was kind of like, oh, sampling is fine, and then it was like, no, if you have even a fragment that you sample, then you got to have a license for that. So, but music is kind of an odd thing anyway.
It turned it all formulaic. There's a fee.
Yeah.
Just pay the fee.
Right. If somebody allows you to, I think. Something along those lines, right? And music is it's an interesting precedent, but it's also odd in lots of ways, because you have like the kind of the sheet music has one kind of licensing, and the performance has a different kind of licensing, and in the lyrics, and there's a lot of people, a lot of entities involved, and they've worked out some of these things where you can't. But then you can buy songs. You can buy songs with stems so that you can pull it apart and insert your own versions of things. You can like take off the vocals or take off the bass line or whatever and remix it and make your own version. And so it's an interesting precedent. I don't think it applies it directly, but I think it kind of points to how things are going to evolve. So the one interesting thing that Alsop said was, if you have a license to the material, like if you just buy a book, scan it in, and then train on it, completely fine, fair use. The copyright owners can't complain about it, etc. Unless, of course, you do something like you spit out an infringing result. But if you're not doing that, if you're just sort of generally learning about it or learning the style or the facts or whatever, then it's fine. But he said, if you didn't actually have a license to the versions of things that you trained on, then they can sue you and say, well, you infringed because you had an unlicensed version. As far as anybody can tell, all of the big trained models are trained on giant corpuses that are full of just copies of everything. And so it's pretty unclear how that's going to be worked out, although it seems like we're getting to the consensus that it needs to be worked out. And so I think we're gonna, I don't know, we'll see what happens.
What I didn't see, haven't looked at your slides, is anybody talking about the photography databases. So you store stuff on Amazon store, they have some rights to use your music or your pictures.
Yeah, I don't know what they're claiming for that on the various places where you can store images. But yeah, that's another interesting issue, is whether they have legal access to it and how they train on it, and then what happens to the result. And
but even in images, it's a huge area. For example, the Disney case, the Disney is presenting like picture after picture after picture generated by generative AI that clearly looks like a Disney character. So if you go to a generative AI and say, produce a Mickey Mouse for me, right? Produce an Elsa from Frozen or something like that, it will generate
Right.
a version, produce a happy Elsa from Frozen. It will
Right.
produce
Right.
something that is clearly infringing on.
Well, so first of all, you could probably ask for a non-infringing Mickey now, because there is a non-infringing.
Sure,
Mickey.
because Mickey's now, Mickey's, the copyright on that is fine, but if we take something that they do actually.
Sure.
They'll have
Sure.
like rights to, like Elsa, for example.
Well, so it's gonna be interesting how this evolves, because, first of all, that's generally correct, but you can make, there are exceptions even for things that are strongly copyright protected, right? So if my intention in making something is to create a parody,
Yes,
that's a big exception, completely
sure,
protected.
there are exceptions, there are parody exceptions, but for example.
And also, if I'm just doing it for my private use, because I want to make something for my daughter,
Right.
or granddaughter, or whatever, and it's not going to go anywhere, then that probably also is fair use, probably be fine too. But yeah, I think what's going to evolve is that there's going to be some mechanism where you can somehow indicate intent so that you can make non-infringing uses,
Right.
and then for things that would normally be infringed, I think they're going to be systems or services that will determine whether something seems to be infringing or not. And then either tell you can't use it, or they'll say, well, you can use it for this purpose for this much money.
Right, I mean, this is also one of the arguments, because the claim from many of the generative AI companies to Disney has been, it's impossible for us to prevent people using our system to create infringing materials, because otherwise the whole generative AI system wouldn't work.
Right.
And yet Disney points out, well, of course you could, because you've got filters for nudity and obscene materials. So why can't you create one for Disney copyright materials? So So I mean, there does seem to be some real controversy there.
Yeah.
On that particular point, right?
Yeah. Well, yeah. I think what you ought to be able to say is make a character like this character, a non-infringing equivalent of this character.
Right.
Right. And then you ought to be able to say like how far.
Right, you need to be able to determine, if I was to produce a zombie version of Bart Simpson, is that infringing or not, right?
Right.
Right, but as soon as you say Bart Simpson, it has to produce something that a man in the street would associate with Bart Simpson, so therefore it almost has to be infringing, right? Do you know what I'm saying?
Well, kind of. What was the series that was like Star Trek but wasn't Star Trek?
Below Decks.
What's that?
Below Decks.
No. Because that's part of that universe.
Spaceballs or
No. Oh, yeah, that was a parody, but not
Orville.
Orville.
Yeah.
Orville was very like Star Trek, but was not infringing.
Right.
It was extremely close, but different characters, like a very similar ship, but different.
Right.
And
Orville was satire, wasn't it?
it was not. It had some satire in it,
I
but
thought it was
not,
satire.
It was not a strict parody. It had its own.
Okay.
It had its own storylines, its own logic.
But it was a comedy, was it not?
Galaxy Quest. It's not.
Yeah, it was not Galaxy Quest.
But it was a comedy, was it not?
It was one of those mixed things. So I would say it was
Okay. It was a comedy.
60%, 60 to 80% comedy.
Okay, there we go.
Right,
a
but it had
comedy.
lots of drama. It had it was all mock drama, but but I think that's a good example of, like, you could say an Elsa-like character, but not infringing, and make it Greek.
So I have a general question, Stephen. You're talking about generative AI, ML. I mean, is ChatGPT and Claude, that's generative AI, ML? Yes.
Well, okay, so I think yes, They are. I
But you're
think,
talking about a more narrowly trained, focused type AI ML, right?
no, I think all these problems apply to anything that's generative. Right? If you build a system that just classifies and you show it a picture or text and it says, this is, this is a story about Donald Duck, then that's not generative. If you say, write me a story where Donald Duck does this, right, and make it a video that looks exactly like Disney art, then that's generative and would be infringing by default, unless you.
So I think we've seen recently people asking for code and then someone complaining, this is exactly my code that's on GitHub.
Yeah, or New York Times was able to show that the generative AI, given the correct prompt, was able to exactly reproduce New York Times articles. Right?
Yeah. Yeah, I think that well, that's why I'm saying if you give it the right prompt, I think there's a couple things involved. If you give it the right prompt, then it's going to target some specific thing. But really, for you to be able to get exact content out probably means that whatever that is shows up multiple times so that it treats it as ground truth. And that definitely happens in
Or
code.
it's so unique that there is only one thing you're trying to.
Perhaps, but I think that my impression is that unique stuff tends not to be like learned unless it's being pointed to by a lot of things. I mean, a lot of things pointing at something in a sense gives it, like in the Google search sense, gives it multiple copies because multiple things are referring to it. But so New York Times case is probably lots of things pointing at that article as the explanation for something. For code, I think code gets shared, code snippets get shared and reused so much that either there's multiple places pointing at that GitHub, at that particular Git repo, or that code. I think usually when I'm have like vibe coding results from Google or whatever, I think it's just that those code sequences show up so many places that that's what it wants. That's what it goes to, right? So it's tricky. Things like not all code is copyrightable, right? If it's too like there's only one way to do something, if it's too like formulaic, if it's well known, there's like a certain
I think the well-known rule has been thrown out. The court says everything is well.
yeah, that's kind of
I haven't seen anybody pass the, this is unique invention. No one else was smart enough to think of this.
well, so I think the one thing that people probably misperceive about code is that the logic of the code, what the code does, is not protected by copyright, right? If you rename all the variables, rename all the functions, rename all the files, reformat it, and especially if you refactor the code into different organization, even if all the actual lines of code are identical still, it would not be infringing copyright wise. Right? Because that's only protectable by patent. And most of the time software is not patentable. So
yeah, I was thinking how trademark might enter to sure it does.
no, trademark's even less because trademark has all the restrictions of whether something's used in trade and when and if it's broad enough. And I actually read began registering Insta.com in 1999 and got rejected because I wasn't using it commercially yet. And so that's even more narrow. But yeah. So I mean, there have been big lawsuits over like a few lines of code, right? But at the same time, I think this went back and forth, and I can't remember for sure how it ended up, but the API, what was it, the Java API?
Yeah, right.
Right? The Java API was ruled as not infringing for Android to have made a copy of it, for Google to essentially have their own version of Java. And they fought back and forth and went back and forth and back and forth, and I don't remember who finally won.
Google did finally win.
I thought Google finally won.
Yeah, they did. Yeah.
There was some extra thing maybe, but I don't think it had any consequence. But that's an example of where you actually had structure and names that were chosen, but it was just the interface, and at some point they decided that needed that is
Sun Microsystems versus Microsoft.
yes. Well, okay, yeah. So that was the first whole thing, was Sun and Microsoft fighting with each other over the same
J Sharp, right? Wasn't that J Sharp thing, right?
Well, there was that. No, it was J Sharp versus JavaScript, but then Java versus C Sharp.
Oh, okay.
Because C Sharp is a 80% plus rip off of Java, where they corrected things.
Because if I recalled, they got sued over J Sharp. Sun was awarded the win, and then Microsoft then did C Sharp. They're like, well, it's not exactly so fine, right? And then I think Sun sued them again, except they won on C Sharp, and then J Sharp hasn't been seen since 2005.
Right. So anyway,
yeah.
So there's all kinds of interesting history that kind of affects all of this. The interesting question. So I think if it's public code, it's
Stephen.
Yeah.
Can you stop sharing your screen so we can see the discussion?
Oh.
Unless you're going to talk about the slides.
Well, we're about to move on, but yes.
That's fine. That's fine.
Let's see if there's anything else here, but I'll toggle back and forth. That's fine. Okay, so let's go to the next one. So Meta had a similar case that happened that was decided right after the LSIP case. They're still fighting that one out, but they also basically won with fair use. Although that one's kind of narrow. They basically said that the people who sued didn't clearly show damage. And so that's going to be that's the other problem, is that it's like, okay, the guy says, oh, they returned my code, but he would have to, under this kind of thinking, he would have to prove that he lost out somehow because somebody else used it. And that's pretty rough to get over. But the other thing I want to point out is this, is Japan they did a revision of the copyright laws, and I think it was 2018 or 2019. I think it was 2019. And then they sort of strengthened it recently, like last year, I think. And they just basically decided that copyright was not going to be an issue, essentially so that they could actually compete in AI and machine learning. They were not going to let that hold them back.
Isn't there some international agreement? Well,
there is what was that? Berne Convention was the old one. I don't know if there might be, I think there's a new one too. Yeah, that's a good question. I'll stop sharing for a second. So I stopped sharing, but the screen's blank. So how's that supposed to work?
We see you fine.
Oh, okay. So yeah, it's an interesting question. because of the essentially treaties between the countries, they're supposed to treat copyright and patents in a pretty uniform way.
China obviously does not.
Yeah, I think they sort of do, but not really. So, you know. They're part of the whole patent system, so you can get a China patent. It doesn't sound like fun, but so anyway, okay, so let's go back. I'm gonna go back to sharing. Yeah. Okay, so this is sort of my inference from these, and it is basically what we've been discussing. You know, seems to be considered a fair use generally, as long as you didn't start with pirated works, which is going to be an interesting problem that everybody's going to have to solve somehow. And then not every use is going to be fair use, depending on what you output. But probably more than people think, unless you're infringing on Disney and a few other places, right? So, okay, so how's this affect homebrew robotics? I think that I think a lot of the things that we're going to find interesting, and we're already finding interesting to work with, start with some of these systems that have been trained on this material. And when it's trained by somebody else, we probably don't have to worry too much about it.
Until you make money, nobody cares.
Yeah, well, that is definitely true, right? And to some extent, like I have held myself back in a whole bunch of circumstances because I was trying to do the proper thing. And I realized that for the most part, I should have had the mindset of nobody cares until you make money. And then I'll figure it out.
It's easier to apologize than to get permission.
Well, you know, once you start making money, you can then you have something to make a deal with. You'd be like, okay, you got a point. Why don't we work out an agreement, right? And in most cases, you probably could do that. And so
It's true in the patent. So IBM famously, patented the proton, so they had a pretty strong case of never infringing on anybody's work. If you want to sue us, let us show you what we can sue you against.
That only works for 20 years though, because then all those become public domain. So, I mean, that's why a lot of things are trade secret, because patent only lasts for about 20 years. Trade secrets potentially could last much longer. So, okay. So, any questions about any of that, or any comments or arguments, or okay?
The White House issued a document about artificial intelligence recently.
Yeah, I read like the overview of it. To me, it sounds like their thinking is similar to what Japan decided is where they think it should be, but it doesn't seem like it really changed anything. It's just sort of where they would like it to go. So I'm not quite sure what kind of implementation might come out of that, but yeah, I think I don't know. We'll see. I have a lot of writer and other, artistic friends who were extremely worried and upset about, the use of copyright stuff, and I understand that.
To make a living?
Yeah. I was optimistic that it really wasn't going to really destroy artistic works, right? And I think we're not, like, it's pretty interesting. I mean, definitely, you can make interesting images and videos a heck of a lot easier than you could before. But in terms of code and coherent text,
we're in this flux state. So, as you know now, if you use AI to generate code, it is both wondrous and horrible. So I am literally 100 times more productive coding now than I was 2 months ago.
really?
But only because I recognize the shit that's coming out of the AI, and I'm willing to let it generate all the scaffolding, and I'll fix the shit.
It's a very good boilerplate generator.
Yeah.
But if you
I
don't
don't-
recognize the shit, you're gonna end up with a lot of bad stuff.
I haven't delved into it a huge amount, but I kind of have, it's in my IDE, and I get a few lines at a time that help me about, I don't know, 50% of the time. And I just have to ignore the rest. Well, I probably ignore like 90% of it, but then the stuff I let through, and then it guesses what I want sometimes, but not usually.
I'm very good at creating all the background it needs
Yeah.
to generate fairly good solutions. But again, you can never believe that what it says is true.
Yeah, the funny thing also is, like, depending on how much context it understands, doesn't
Right.
actually, but and depending on what languages you're using, because of how much of what is on the internet, it's been really good at generating random like web front ends for debugging robot stuff. But you ask it to write C++, and it really doesn't understand pointers.
Yeah, most of my stuff's been C++.
Yeah.
Steven,
Trying to write C++
Dillo's
with it is a voyage of suffering, and then using it to write web HTML and JavaScript has been pretty
Steven.
straightforward.
Yeah.
Dillo in Zoomland has a question. Go ahead, Dillo.
Yeah, I just also wanted to throw my hand in at thoughts in on the LLM code front, because I have been using it to write code for my rover. And it's kind of like similar observations. It's kind of like having an intern. You tell it, I've had it help me out with some optical drift, optical flow based course correction, and it gets all the math, and it gets all of the algorithms involving like angle, depth, into the scene, per pixel, how many pixels in an inch, to figure out like how far it's drifting, how far the rover is drifting off course, how far it needs to turn to come back, how far the wheels need to turn to come back onto course. It gets that really well, but it does it in the style of like a junior programmer who isn't really sure of what they're doing. And so it's incredibly densely commented. It's like most of my code is in Python. So it will do like, okay, I'm going to do this, try accept. And then now we're going to do this, try accept. And now we're going to do this, and so it's try accept, try accept, try accept, try. And I'm like, the whole idea behind try and accept, in Python is that you're going to do a block of something. And the idea is that you hope it succeeds. And if it does, then it should just do the whole task. And you should be like and so, yeah, it's like pretty obvious that it's trained on a bunch of web school examples and student class submissions and very kind of halting, stilted, really kind of unsure of yourself style. But it gets the math right. And it also suggested for this recent thing that I've been working on, which is a spherical panorama. So the rover now does like a Curiosity style 270-degree panorama. I've got the camera, I've got an OD light on a pan tilt, and it goes around.
Before we get too far out into the toolies here, we need to start wrapping this segment up and moving into.
Yeah, no, I'm gonna be quick here. I'm just gonna wrap up. And so the one suggestion that it came out with, which I hadn't thought of, was, you could take because I'm using an OD light, and it's like, you could use like the depth eye API, X-Link in, X-Link out, to feed the OD pictures that have already been taken, and just basically use it as a mini GPU to stitch together images you've already taken, rather than take an image, save it, hold on to it, and try and stitch it all together at once. You could use this as like a general GPU. And I'm like, I never thought of that. That's actually a really cool idea.
Yeah,
I have to go back and I have to like basically edit the code and massage it into something that I can stand to look at, and something that actually would make sense to somebody.
Yeah. Okay. So yeah, I think that's a good example of what I think of as what the LLMs are really doing, is that they're really interesting search engines. So if there are examples out there that are close to what you're asking about, it will kind of pull back. It'll give you a composite of it, and it'll even try to fit it into your situation. But it's basically returning, that well-known code to do something. It's just easier and better than trying to, do the raw search for it and then adapt it, etc. But as soon as you ask it for something that's unusual or is essentially not really publicly solved, then it's useless.
It falls apart.
Yeah, exactly. Okay.
Everything I don't like about LLMs will change tomorrow.
Yeah.
If you're on YouTube every day, this is the news, better than everything before.
Yep.
And then at the very end, you reference an NVIDIA talk.
Yep.
And what does it say at the very end? We've already consumed all the information there is.
Yep.
There isn't anything more to consume.
Yep.
And the amount of information that's available for robotics, the action response stuff is very small.
Yeah.
You have reached the end of the internet.
Yeah. Start over. Okay, so let's go through these real quick. We don't have to spend a whole lot of time on them, but we
need to get on to Survey.
Yeah, so this is a pretty good article in the current version of Make, and it does actually go into doing using a simulator to do sim to real training for the robot dog. So that's pretty cool. They actually talk about the issues with it and how to get past it and stuff. It's a nice little article. This is one that just came out recently that there are a number of different projects doing this, and Google's been doing it for a while, but they seem to be getting more sophisticated, where they're just training on videos of real world things and being able to learn motion planning and physics and all of that effectively from that. And so this is one where you can see they start out with a robot arm actually doing something, and you can see in the center there, they've sort of simplified it. It's sort of like the spherical cow version of that scene. Right? So they got these like big voxels, and they're reasoning about them at an interesting resolution, right? And then the net result is they learn how to do that movement and manipulation, and then they're actually able to run it on a real robot and control the motion. Learning directly from the videos. So pretty amazing. And it's still token based. Like not everything is going to be LLM token based, but it's pretty surprising how much they've been, we've been able to fit into that model. So this is, Google's Gemini and doing a similar thing. Both Google and NVIDIA, their big thing is having simulators where they can vary the simulation in lots of ways so that the model gets trained, doesn't overfit and gets trained in more generally, and they can effectively learn a lot in a short amount of time. And so this is from that video, which was called the Physical Turing Test, and they're doing like 100,000 training sessions in short order. It very quickly in parallel across a bunch of GPUs, and then they run it basically for the first time on a robot, and they're able to control the robot pretty well with a lot of like fast action. So this is just a screen.
Is this part of Groot and OmniVision and all that stuff?
Yes, I think so.
GR00T. Yeah. Okay. What's that big processor?
Yeah. So yeah, if you click on that video, it's a really interesting, fun video. And then there's a bunch of other references. Most of these are related to reinforcement learning.
That's using the Blackwell, yeah.
Yeah. So there's a number of interesting things in here. So this book gets referred to quite a bit, and Stanford has the actual PDF there. And then there's videos about it and other things related to it. So
you've posted this slide deck on the mailing list, right?
I did, yeah.
Okay,
so
cool. We can continue the discussion on the mailing list.
Right. And there you go. Over to you.
Thank you, Stephen. That was awesome.
All right, thanks.
So I can sort of use this table.
Yeah, here, let me move and use the whole table. Unless you need a victim.
Hey, Survey, do you got your robot with you?
I do, yes.
Let me get a beauty shot before you get started, or it didn't happen. Stand in front of the camera. Stand in front of the camera, smile.
Okay.
There we go. Action, work it.
The robot or me?
Like you're coming down the runway.
Well, wait, you gotta get the cone in there, right?
Oh, yeah.
That's the whole deal with this
All
robot.
right, take two.
Cone stuff.
Gotta go goal.
All righty.
All righty, go ahead.
Handy in a second.
What's your robot's name?
It is called the mobile robot.
Okay, is that capital T, capital H, capital E?
Yeah, like the ultimate one.
Okay, got it. I like that.
Yeah.
We'll settle for nothing less than total world domination, right, Survey?
Absolutely.
All right, absolutely.
Okay, let's try a screenshot. Let me know. And Camp, if you don't mind pinning both this video and the screenshot, that could be cool because there will be stuff on the table as well.
Okay. When you do the share screen though, it overwrites the spotlight. But go ahead.
No worries. I can also switch between sharing and not sharing.
Go ahead.
Cool. Hey, my first time actually here at this meeting, so hi to a lot of you folks here. I've seen some of you at the RoboMagellan competition before. But
new guy buys the mail.
If anything is open at 9:30 when we finish. Yeah, but I'll be talking about the mobile robot. Are folks familiar with RoboMagellan competition? Okay.
Yes.
Everyone. Okay, I'll just kind of very quickly go over the rules because
right? Just for folks that maybe are not online. So it was inspired by the DARPA challenge, and it's autonomous navigation in an outdoor environment, but like made much smaller to be run in like a park setting, right? There are these cones that are located around the park. There's a start cone and a goal cone, and then some bonus cones, and you're given the GPS coordinates for these cones. The goal is to autonomously navigate from the start to the goal cone, and you get extra points if you hit the bonus cones as well. But you have to make contact with the cone, right? So actually, let's go ahead and this is the interactive bit for the session, but let's go ahead and design this together, right? So let's say we have a cardboard box. I'm waving a cardboard box in the video, trust me. And the cardboard box has to make its way from the start cone to the finish cone. And if it does that quickly, you get mostly just honor and pride, but you know, bragging rights. Yeah, exactly. But let's say we call this robot the Shoebox 9000, right? What is something that the Shoebox 9000 would need in order to complete that course?
Something to move it.
Something to move it. So like motors, cool. Wheels, motors,
Yeah.
some sort of localization. Yeah, like a GPS sensor, you know, LiDAR sensor.
You need a camera to see the cone.
Camera to see the
Camera.
cone. Yeah, we'll get into why that comes in handy.
Sensors necessarily need to be a camera.
Yeah, totally.
Or it seems sensors tech.
And I actually, before the meeting, this is hopefully fair play, but in terms of AI, ML, and copyright stuff, but I asked ChatGPT to be like, add all of these things to a shoebox, and
That's awesome.
It did
That
that.
actually looks a lot better than I would have expected.
Right? I was very impressed.
I expect to see that robot at the next challenge meeting, okay?
I see it's those Spark Fun wheels.
Yeah.
It's on every Amazon listing ever.
Yeah. Yeah. So yeah, some amount of compute. So a Raspberry Pi, for example, a couple of motors to power the thing, wheels to be able to move, batteries and GPS, whatnot, right? Yeah. And that's kind of where I started as well with this project, right? And then the process of finding, fixing, testing, and repeating begins, right? Yeah, you can leave the rave there.
Hey, we don't do this because it's easy.
But let's say we go ahead and run this in the field. Like you might find that the shoebox is too flimsy, right? So how do we fix it? I just got a 3D printer. So I was like, let me, 3D print a chassis and make it a little bit more strong. Also 3D printed some wheels. The picture on the right is actually the first version of this robot. And let's call it, Shoebox 9001. So you go to your local park, try to joystick it around, see how it does. And the goal here was to test, are the motors powerful enough?
So here, are you just radio control with electronic speed controllers or something?
Yeah, there's two motor drivers that are controlling 2 motors each. So it's got 4 motors. It's a beefy robot. And
are you radio controlled or what?
Oh yeah, like a joystick, like a Xbox controller type joystick.
Cool.
So the Raspberry Pi has like a Bluetooth dongle. And through that process of like finding issues, fixing issues, testing it out, I kind of ended up with Shoebox 9005, right? Which now has a Raspberry Pi for motors. It has the router to network stuff. And it's got like a nice handle also to carry it. The wheels are a little bit bigger because I noticed there wasn't enough traction. And stuff of that sort. But the most interesting thing is that it has a mobile phone in the front. So instead of like trying to integrate a whole bunch of sensors, I was like, let me, the phone actually has all these sensors, right? It has a great GPS, compass, IMU, not one, not two, but like 3 cameras, and tons of compute, right? So this can totally be my sensor bay. Can I send the data, use this as my sensor base, send the data to the Raspberry Pi, and have the Raspberry Pi just send the motor controller commands out? And it kind of worked. Sorry, what were you saying online?
I'm trying to visualize where the router comes into play here.
Yeah, great question. So the phone, because I have an iPhone, I couldn't figure out how to get a wired connection to the Raspberry Pi. So I cheated and I created a local network with a little router that both the Raspberry Pi and the phone connect to. So then
Why wouldn't you use the phone's hotspot as a hotspot?
Yeah, I wasn't able to figure that out. So I decided to take the easy way. But that could be an improvement in the future for sure. I definitely did not want to go hit the internet and come back down, because the latency for that is too high.
Okay.
And I'm you know.
Yeah, it depends on whether the hotspot allows a client to actually connect to the phone.
Yeah.
Or if it just
I
passes.
do my raw stuff on a phone so I can do demonstrations so I can do demonstrations remotely.
What accuracy did you get from GNSS?
Yeah, that's actually the next slide. So just hang on there. Perfect. When I was doing that testing, I came across 2 additional problems. One was that, like, just with GPS, you cannot reach the cone because it's got like about a 5-foot accuracy. And then the second thing was more mechanical. It just kept getting stuck in like thick grass. Either both the wheels would just be spinning, or I'm not a mechanical engineer, so like I had to, you know, get some help from some friends to figure out what was going on. But we'll dive into each of these specifically.
Consider on the GNSS using one of the newer GNSS modules. The newer GNSS modules have, like we're using one that have 1,500 correlators on it, whereas one on a phone might have 30, plus can access all of E6B, yeah, the high accuracy. You can use Galileo high accuracy service.
Yeah.
Now the spec on Galileo high accuracy service is 30 centimeters without ground correction.
Okay.
So RoboMagellan not supposed to allow you to.
Oh, really?
Yeah.
No, you can't use. You're not supposed to use ground correction.
There's no ground correction.
You're free to use whatever the satellite sent you.
So with Galileo high accuracy service, you don't need to use ground correction. What happens is that with Galileo high accuracy service, it sends a correction signal for ionospheric distortion along with the satellite signal. And
question from Zoom. What is the current question being asked?
Oh, we're discussing other like higher resolution GPS chips. But I think in general, like even with a very high resolution, like let's say you get to maybe 8 inches, 12 inches or so, right?
Still not enough.
Still not enough, exactly.
And we found mobile. And we did measurements on this without ground correction, using all of the correlators, using Galileo high accuracy service, as well as using all of the ground correction, all of the Galileo high accuracy stuff, using all available satellite constellations, including GLONASS, GPS, Baidu, and everything that was available, and all of our correlators. Without ground correction, we were getting about 5 centimeters. So
using the high accuracy service
and using high precision antennas as well. I mean, just maxing out on everything that we could do.
I'm the focus guy. Yes.
Yes.
And so it's
next to buildings.
Maybe not. Yeah.
So that's one of the things too about like the GNSS on phones. It's just because they're so small, the antennas are terrible typically. So cell phones still heavily rely on cell tower triangulation for doing
GNSS, because they just don't have a good enough antenna to get to pick up the GPS signals without like open sky. Like,
Yeah.
So
another important thing about this kind of like GPS accuracy, like GPSing the cone alone, is that the cones kind of get migrated around during RoboMagellan as people like kick the cones. The robots push them when they hit them. So they do like kind of scoot around. And then also, even one of the other things is like with very high accuracy GPS is that you get to the point where you're starting to talk about like things like earth tide effects and the motion of things, and then like
Good the maps.
eventually you get your GPS to be accurate enough, and then you come back 10 years later and continental drift gets you.
Part of my RoboMagellan is every time it hits a cone, it records and updates its internal logic of where that cone is.
And I think that's the exciting part about like working on a RoboMagellan project. It's like there's not one way to solve a problem. There's like many different ways, and I'm choosing this particular way, but you can definitely pick another way. So general consensus, let's say, with the technology that we have on the phone, we need a different way of getting closer. Like the GPS isn't going to get us there.
I remember when 5 foot was considered good accurate.
Yeah.
GPS gets you in the ballpark.
It gets you in the ballpark.
5 foot is pretty incredible, actually.
And so what we can do is we have, the 3 cameras on the phone. But if we were able to detect where the cone is in the camera image, then we can kind of move towards it as we go forward until we make contact, right? So if the cone is towards the left, you kind of, turn to the left, kind of centering the cone back in. If it's to the right, turn to the right. And you can kind of do this. So this is YOLO is a model that's available, and it is an object detection model. It's really fast and can detect people, bicycles, cars, you name it. Unfortunately, it doesn't have a traffic cone class in it. And that's kind of where this concept of fine-tuning a model comes into play. So no copyright images here. I went to the park myself with my cone and collected images. But yeah, I collected around 75 or so images, labeled them manually in RoboFlow, and fine-tuned the model to only detect cones. Like it only spits out one class, cone or no cone, right? And it gives you the center of the cone, so you kind of know where it is in the image, the height and the width, which is kind of important as well to get an estimate of how close you are to the cone. And the most important thing is like, how confident is it that this is the cone, right? So that helps determine like where the threshold should be for what is a cone and what is not a cone. But the behavior then becomes get close to the cone with the GPS, get in the right ballpark, and then to touch the cone, you kind of, this is what I came up with. You rotate in a circle until you see the cone, and then move towards it while keeping it in the center. That gave birth to Shoebox 9006. This is maybe 6 months ago.
It's the April one.
It's the April one, yeah. So you can see the robot was kind of misaligned. GPS did not get it super close, and it is moving in a circle to find the cone. Everyone is being very supportive and not getting in front of the robot, which is awesome. Yeah.
Somebody's gonna have to wear a big red dress at some point, big orange dress.
Yeah, yeah.
Wide bottom.
Literally have a traffic cone orange shirt that says RoboMagellan on it.
What was the
Or just
speed
tall socks.
for the cone closing part of your algorithm?
Yeah, so I'm running the model on the phone, which gives me about 8 hertz, 7 to 8 hertz of information. I run my control loop at like 10, so nothing crazy.
Okay.
Yeah.
Is the app a web app or?
Great question. It is a web app.
Yeah, I thought.
And you can scan that QR code, point it at a cone, and get a sense of, if it works or not.
Open camera.
There is a model that takes like 10 seconds or so to load.
Yeah, I love how it's sitting on 95%.
Yeah.
Did you consider using optical flow with the object identifier to
Yeah,
increase
there it is. Got it.
Yeah, I did not, but that's an interesting idea for sure. Yeah,
because you can then increase your frame FPS rate. You identify the object,
absolutely.
use optical flow to track it, and then you can increase your frame rate and close it a bit faster.
It's working,
This is Dillo. Yeah, optical flow is actually a lot easier than it sounds. I've done a good bit of work with this on my rover, as I was talking about before. Definitely give it a look.
Okay, yeah, we'll check it out.
This is the.
In fact, I actually have I can post a demo video or link you to a demo video of where I'm having my rover follow me around using a YOLO model people follower. Basically it's a YOLO model people follower.
Oh yeah, that's cool. Nice.
Have you tried using, is this compiled with WASM?
It's Tensor Flow, it's TFJS, TensorFlow JavaScript.
Yeah.
So there's like a conversion process someone figured out.
Are you using web workers or web? What are they? The browser threads?
Yes, exactly.
Okay.
Yeah. Yeah. So that's why you kind of only get like, 6 to 8 frames per second.
That would be 0.8. I need a new phone.
You need a new phone. Yeah, you can guess like with a new phone.
Did you consider something like a CNN or anything like that? Why YOLO?
Mostly because YOLO, I had worked with it previously, so I kind of leaned on my experience of training YOLO. And I knew they keep like releasing better models as well, like really small ones too. So there are 5 or 6 different like sizes of models, and I'm using the nano model, which that's why it runs at like 10 hertz or 8 hertz on the phone. If you use like the medium or the large model, it'll be like half a hertz.
Right.
Yeah. Okay. Definitely close the app because it will drain your battery like crazy. But then with that in mind, like we can now reach the cone, so that's good. Let's now talk about getting stuck in grass, right? I am not a mechanical engineer, so I had to lean on my mechanical engineering friends to help me out with this one. But I skipped out on the suspension on my robot because I was like, who needs suspension? Why overcomplicate my robot? And then kind of realized like every RC car or outdoor robot comes with suspension, and it's for good reason. Yeah. It's so that all 4 wheels maintain contact with the ground and you get like good traction on all wheels. Right? So you get like a nice balance of traction. But I did not want to rework my entire chassis, again, kind of being lazy. This is a side project. So I kind of was looking at different kinds of wheels and came across these like non-pneumatic shape-shifting wheels, and decided to incorporate that into my wheel structure, right? So again, going back to my new toy, the 3D printer, and a chance to use a new filament, the TPU, nice and squishy filament, printed out these little squishy caps that go all around the wheel, and the robot's weight essentially presses down on them and creates a suspension, right? And when we test that out again, this is again a video from the April run, but it has basically no problems in tall grass now, which was very exciting. And
how did you attach the TPU?
I super glued it.
Okay.
Yeah. Or no, actually hot gut. I hot glued it.
Yeah.
So this is kind of the journey from like shoebox 9000 to 9010. The video on the right is now from the June event, the June Magellan event. Nathan and I have been throwing these every quarter.
Yep, that's the idea.
And you'll notice one thing actually that's different in this one. There's a tail or a whisker going off the back in the previous version, there was the whisker was kind of in the front of the robot, but that was messing with the object detection. It was like in the view of the cameras. So I kind of like put that back.
You're allowed 4 by 4 by 4 feet, so I expect a foot or two to start coming out of the side.
Yeah, exactly. But it can, it can feel daunting to go from like a shoebox idea to like a working robot. But if you kind of take it step by step of find the new issue.
No, that's all. I
fix the
think
new
what's really
issues.
awesome is that you've built it around the phone, because
Mhm.
that's a very resourceful brain for a mobile robot.
And so the whisker's just there, so you make contact with the cone.
Exactly. Yeah.
Yeah, I've saw guys at the
and-
last RoboMagellan with whiskers coming out of the side of their robot, so they could just drive past the bonus cones and touch them.
Nice. Yeah, that's a great way to get more speed. But yeah, there's a couple of us that, hang out and work on our robots. Every quarter we run them. And there's a good community, especially at like Brew Robotics, right? That can help you out if you're stuck on some stuff.
You guys gonna do this again in September?
Oh, yeah.
Yep.
There you go. There's your deadline.
Yeah, September, December. So yeah, come join us. Like if you have any problems or questions,
Hey,
ask.
man, you gotta do it. No. RoboMagellan, rain or shine.
We gotta
Just put a plastic bag over it.
umbrella on it.
Yeah. I have a demo of like, if anyone is interested, I can turn my slides off. But then because I have to connect my computer to the local network on the robot, I will not be able to share slides anymore. I want to share this cool video. This is the video from the camera on the robot. So like the phone's camera, right? I recorded this in this room earlier today. So the robot kind of like was turning in place. It found the cone, then it starts approaching it. Now it's doing that 180-degree turn. It probably whacked it with its tail and is going forward.
So you were driving that with a joystick?
No. So this is autonomous. I was hoping to play this video as I do the demo, but logistically that is not possible to do. So I'll do the
So
demo
the
now.
robot was just driving around, avoiding obstacles or something?
No, the robot, I basically positioned the robot facing away from the cone and said, like, run the, cone touch behavior. So what it did was go in a circle first, just kind of on the spot moving until it saw the cone, and then it starts driving towards the cone, keeping it in the center. And that's like a PID loop to keep it in the center.
So the Pi is driving the wheels, and the phone's communicating with the Pi through that router?
That's correct. Yeah. So the phone is essentially giving all of the data plus running the model, the sensor data and running the model. So the compass is used to turn in place. You know where you started, you can kind of do a 360 from there. It runs the model, sends all that data to the Pi, and then the Pi has Python code that runs the behaviors, right? And has the logic for what to do when.
So, okay, and driving the wheels is a function of what the camera sees. Does the yellow code cover that some way, shape, or form? It just centers it up, and you tell it to drive forward, right?
Could you say that again?
I'm trying to understand the connection between YOLO and driving the wheels. And I think I've answered my own question. YOLO knows that the cone's centered, and then you just telling the wheels to go forward at that point, right?
It's a little bit slightly more sophisticated than that, but essentially that, right? So YOLO just gives you the XY coordinates and the height and width of your detected object. You can do what you choose, what you want to do with that data. And what I'm doing is like essentially building a PID loop, where the distance from the center of the image is what you're trying to minimize to drive that down to 0. So your set point is 0 in the center of the image. Now, if the cone is to the left of it, right? So you would have sort of, I think I can annotate, right? No, I can't. Okay, anyways, the distance between the center of the image and where you detect your cone over here becomes your, you know, error. Yeah, input to the PID, and you try to correct it.
It's trying to center the cone, correct?
Yes, exactly. Yeah. One other thing I wanted to share was some lessons learned while training the model. So I think this would be interesting if someone is trying to, you know, fine tune a model. First version of the model, these orange curtains that I have in my room were also being detected as cones. Then some other random objects would also get picked up as cones. And they were relatively high confidence, like 88% for that curtain, 72-ish% for the, you know, whatever artifacts it's finding. And that's kind of when I created this mental model of like the YOLO is trained to basically detect triangular things. I've trained it to detect triangular things and orange things, but I also need to supply it with images that are non-triangular but orange, and say like there is no cone here. Do not, you know, think there is a cone here, or things that are triangular but not orange, which are very hard to come by. So what I did was take all my cone images and suppress the orangeness and create like a training set that way. Yeah. Synthetically, I think the technical term is synthetic generated data, right? And with that, it does phenomenally well. No problem.
Interesting.
What I was going to try to do is, I'm under the impression I need, for good YOLO confidence, at least a couple, 3,000 pictures.
This is 75. Yeah.
So that,
I was very surprised.
That's not true, apparently. And then I was gonna take a dozen pictures of cone in different light temperatures,
Yeah.
and then synthetically inject it behind the bush, you know, sticking out the edge of a trash can.
Totally. Yeah, you can 100% do that. Just find images of, you know, the environment you're going to operate in and put a bunch of cones in exactly the places you know. Yeah.
And since you know where you put them, you don't have to use RoboFlow.
You don't have to label it. Yeah. RoboFlow also has this interesting thing called a one-shot model. So you can kind of describe, a zero-shot model. You can describe, like, label the cones in this image, and it will do an okay first pass at labeling it. Then you can just kind of go in and say like, yeah, this is okay, move this one, you know, bounding box a little bit. It helps with that labeling process. But for 75 images, it took like half an hour.
RoboFlow's that mix.
Survey?
Yeah.
Survey, we've got a question from Zoom land. Dillo, go ahead.
Yeah, I had a kind of, I guess, more of a fundamental question. I certainly appreciate the you know, using the sensors on your phone. And you mentioned it was an iPhone. I thought that was a fairly closed off development environment. So I guess I'm kind of missing the link, especially like on the earlier versions of like how you get the data from the phone, you know, into the app, and then how that actually like moves the wheels, how you actually talk to the motors.
Yeah. Okay.
Because I understand that that's not, I know that's not exactly like talking to the outside world is not exactly an easy thing, either in Android or in iOS.
Yeah, totally. It's a great question. So what I'm doing is I found I'm using the browser really to run the model, because the YOLO model can run in the browser. And then a browser can make HTTP requests in a loop. So it basically, there's a loop that runs in there that says, oh, I found a cone. There's a callback technically, right? It's JavaScript land, but there's a callback that says, I found a cone. I'm going to make an HTTP request to a server that is running on the Pi and send the data of where the cone is via that HTTP, request.
Okay. So how did you do that before you were using the Pi?
Oh, I never not used the Pi. The Pi was
okay.
Yep. So that's how I get the image, or sorry, the cone location data. But then for high rate like compass and IMU data, you would have to build an app. That is not easily accessible in the browser.
Right.
Fortunately, I found someone, this professor in like Germany, he needed this for his research project, whatever. And he built an app where it works exactly the same way. You put in a input box the request you want to call with the data, and it like sends that at 20 hertz. You can also do it UDP and stream it. It's a really well made.
So you're basically doing it all through web requests, and then
Yes.
Pi is listening and picks up on that, and it goes, oh, you know, that's a motor request, takes apart like the URL or whatever, and
yeah.
What's the name
of that? It's called sensor log, one word. It's like a
Sensor log.
Sensor log. Yep.
Does that also pull the LiDAR data and stuff, or is this an app or a web?
Yeah, it's an app. It does not pull the
okay.
LiDAR data.
Okay.
I found this guy on
You got a LiDAR?
on LinkedIn.
The iPhone Pros have had for the last like 2 or 3 years have LiDAR in them.
Which you can access.
I've sometimes seen that you can't get to it, but
You can.
You can.
In an app, you can, not on the browser. So if you build an app, you can access it. You can in fact use it for 3D scanning an object, which I have done, and then 3D printing it, for example.
Yeah.
So I know you can access it. I just don't know how to build an iPhone app, but you know, Claude does. So
I can do Android.
I haven't written
Vibe coded
in like 7 years when I
Yeah.
used to be a contract iOS guy.
Okay, so you know how. Okay.
I'm rusty.
Okay. Are you less rusty than Claude? That's
a good question.
Yeah.
7 years of out-of-date knowledge versus what?
Okay, I am going to quickly do a demo, and I'll do it on the table because I'm crazy.
Oh man, this will count as table bot challenge.
Yeah.
You get bonus point.
Just for the camera.
You're my hero, Survey. I love live demos.
Hey, don't jinx it yet.
What could possibly go wrong? Wrong.
Hey, want to watch me temp?
that trick never works.
I will
It's,
grab it if it's not falling. Let's see.
You want to do
It does have a
we'll do
handle.
phase 4.
So right now it's doing that turn maneuver. Now it found the cone. It's going to drive towards the cone. I have slowed everything down just to be able to do this on the table. But then it turns back around. It's safe. And
What's with the tape measure on the front?
Hey,
okay.
I'll give you a table bot challenge phase 1 there. That's awesome.
Yes, great. There is a tape measure on the front that is very specifically placed to distribute the weight evenly. Otherwise, it tips backwards sometimes.
That's hilarious.
Nice. Counterweight.
You can't cut it.
That's very nice, Survey. That's very good. Very good show. Very entertained. Thank you very much.
Cool. Thank you, everyone. Thanks for.
Yay.
All right. Well worth the price of admission.
Yeah.
Any other questions? That's awesome. Yeah, build a robot. Join us in September. Join us.
Yeah, I think I think the LiDAR sensor on the iPhones, I think that's a cavity laser, the VC cell. It's like the VLX family of sensors that's on there. So I think it's like a VL53 something.
Well, it's got a lot of points on that LiDAR sensor.
Yeah, and the Face ID LiDAR sensor is actually very high resolution. The depth of field of depth or depth of field is low on it because it only needs to be able to recognize your face, which is generally close to you. But you can scan objects with that sensor really, really well.
basically dual well camera type sensor.
I don't know the
Measures
exact
the-
specifications of it, but the point cloud you get out of it is really high.
Right, but
Yeah,
it measures
it's,
the phase difference between
Okay.
it switches the cell on and off.
Okay.
And then it measures, you have two wells, and then you switch one well on, and then you switch the other well on.
Okay.
And then you use the difference in the phase of the outgoing laser and the two wells to measure the phase difference between them, and that corresponds to the time difference, which corresponds to the distance. Is that the type of system that they're using? I believe that is. The sort of gesture recognition style camera.
I buy it.
Yeah.
According to Apple, the resolution of the LiDAR depth cloud is a 256 by 192 pixels on the depth map.
And they probably interpolate the image over that.
And they quote reliable distance measurement up to 10 meters.
Up to 10 meters.
That's on the outward. The
That's
back.
on the back one.
Yeah.
Yeah, the front facing
the
one.
field of view?
Not listed.
It's this much.
I mean, yeah, the main problem is that when you do that, you need a lot of power to get enough data back so that you can get an accurate correlation of distance.
There's a whole lot of apps, there are 6 of them. You'll walk around your thing on your table and generate a student.
Yeah. Yep.
Yeah.
Any other questions online? That was a good one about like the networking.
All right.
Hi, can I ask a question? This is Pankaj. Hi, Survy. Great job. I am Survy's dad. So thanks for the invite.
Are you building a robot now?
No, I wanted to know, do you know, Survy, are there any similar events happening in India where I would love for you to come and do a similar talk so that, we can do a similar thing for the robotic fanatics here?
That's a good one. Yeah, and my agent is right there. He said if I get a free trip, I can do one.
Hey, you can connect to Zoom from India.
Oh yeah. All the time.
Yeah.
Yeah, no problem.
Yeah, I'm sure there are actually. Yeah, I'm sure there are robotics clubs like this, and I think the Magellan challenge is a really good one because it's broad enough.
Difficult.
Yeah, and deceptively difficult, but also easy to get started. Like you can definitely.
Robot. It's a full-size robot that's doing something that would be useful, and it's not a fighting robot.
Yeah.
Very tempted to make a beer cooler on wheels at this point. Like just.
Congrats, good job.
Big batteries for the refrigeration.
You need to build a robot that brings you to the beer.
Oh yeah.
I was just looking
hack up a mobility scooter.
So the Samsung S24 Ultra has a time of flight sensor.
Okay.
And
nice.
it has it's interesting. It's talking about capturing phase. It can capture up to 120 frames per second.
Okay.
And it's 640 by 480 resolution.
Nice.
Hey.
Yeah,
All right, it's about that time. I want to thank Stephen for the presentation. Survey, that was awesome. Dr. Crawley, thank you for bringing Magni Jr. That's awesome. Tony, I see you back there. How you doing? All right. And so is there anything else before we close here and go into random access? All right, I'll make a motion the meeting be adjourned. Do we have a second? All in
Awesome. Thank
favor,
you,
say
Cam.
aye.
And
Aye.
yeah, thanks Nathan for organizing the AV.
Yeah. And then
All opposed, say
long as
nay.
I-
Ayes have it. Okay, thank you
Sounds
again,
great.
Survey. Thank you, Stephen. Thank you,
Thank you,
Nathan,
Cam.
for setting up the Maker Nexus.
Yeah.
Yeah.
Thank you.
You get some dispersion.
So, hello.
Okay.